Welcome to Transient Stability Analysis using PSSE demonstration video. Now that we have learned how to create the diary file, it is time to perform the simulation on a slightly bigger system. So for this purpose, we have selected IEEE 9 bus system, which we have updated it to include different analysis. So you already saw that instead of on bus 3, instead of one generator we use 3 generators, so we'll be using the same case, and the first analysis we will be performing is the transient stability analysis of angular stability. So we will be checking angular stability for two cases. Number one, for the fault clearance type of 100 millisecond, and then fault clearance type of 200 millisecond, and then we will compare the results of both. So now to perform the simulation, what do we have to do? Number one, we have to open our base case. So first thing you always have to do is open the base case. Once you open the base case, second step is to open your SLD file. So I'm going to go ahead and open my SLD file. So this is step number 1 and 2. Step number 1, open base case. Step number 2, open SLD file. Step number 2 is optional. So if you have SLD file, good. If you do not have any SLD file, no problem. So this is how it is done. So we have this case. Now solve this case. So we are going to solve the case. So once the case is solved, the third step is to convert this case. So now how do we convert the case? For the conversion, let us again go through it. We go to power flow, we go to convert load, we use convert generator and use Z source option. Then we go to convert reconstruct loads. Operation is convert constant MVA load, and we percentage active power will be 100% constant current, reactive power will be 100% constant impedance, and we will be doing this for all the buses, load on all the buses, and we will press convert. So now load is converted. Third step will be, now go to solution again. First perform order and assume all branches in service, and after ordering, prepare the case for switching studies. Solution for switching studies, make sure that you use voltage vector as starting point, because you see here in all the buses the voltages are not exactly 1 per unit. The voltages are either more than 1 per unit or less than per unit, and this is exactly what we want. We want to start from the actual load flow case, not from 1 per unit, because this way our result will be much better. And make sure this factorize before performing solution is checked, and when you press OK, so everything is done. Now your case is converted. Step 3 will be completed when you save this case as a converted case, so that we can use this for other analysis as well. So save this case as CONV. Now this case is different than your load flow case, because on this case now you cannot perform load flow analysis, because you have converted all your generator from voltage source to current source. We are done up till here. Fourth step, if you have a snapshot file, call the snapshot file. If you do not have snapshot file, then first part of step 4 will be to call a diary file. Now you already know how this diary file is created. So we will go to open. From the drop down list, we are going to select dynamic diary file, and we are going to select IEEE 9 updated file. We do not need connect and connect file at this time, so let it be like this. We are starting from initial, so every index should be starting from 1. So this is also okay. Press OK. Now my dynamic data file has opened. So I have all the data here which is required for this study. So we modeled, I already explained that how this generator data will be modeled, the exciter will be modeled, governor will be modeled. In the same way you can model stabilizer data. So once you are done with this, what will be the next step? The next step will be to add some channels into it, which you will record and see in the future. After the simulation is done, we will see them to analyze the result. So how these channels are selected? There are several ways to do it. We will use each way in each kind of analysis. So in this, I'm going to once again go with the most common method, and the most common method is you go to Dynamics and you select Channel Setup Wizard, because with the help of wizard you can select multiple channels at the same time. So number one, here what I'm going to do is I'm going to select my angles only, because angles are important for me, and then I'm going to select the bus voltage. These two kind of thing I need for all the buses, so I am using this wizard to select for all the buses. So let me go ahead and select finish, and 9 channels, total 15 channels have been added. So how can we check the channels? We go to data, we go to channels, and here we have, so we have 1 2 3 4 5, we had 6 machines, so 6 angles are there. And then what do we had? We have 9 bus in the system, so all the 9 buses voltages I am monitoring here. Now the next thing I have to do is I need to check by pressing Control Tab. I'm going to my so what is the simulation we are trying to perform? We will be performing the fault on bus number 4, the HV bus of this generator transformer, and tripping the line. So the line with the largest load is basically the line having the lowest impedance. So what we want to do is we want to reduce the impedance of the system. So for this purpose, what I'm going to do is I'm going to initiate fault on bus number 4, 3-phase fault. For the first analysis, the fault is going to continue for 100 millisecond, and in the second simulation the fault will continue for 200 millisecond, and after the clearance of the fault we will trip the line between bus 4 and 5. So now it is a good idea to monitor the power flow on bus 4 to 5 and bus 4 to 6, so that we can see how the system responded, or how this after this outage, how the power flow changed on the transmission line. So it will be good. So now for this purpose we are going to use single channel selection. So how you can do single channel selection? Single channel selection is also simple. You go to Dynamics and you go to define channel output, simulation output, and here you have bus quantity. From here you can select one bus quantity. Then you have line quantity, load quantity, machine quantity, and miscellaneous quantity. So for now we need line quantity, so I'm going to select line quantity here. So let us select the line. First line is from bus 4 to 5, right? So we go to select bus 4 to bus 5. So this is my first line. So I want to see both active power and the reactive power. If you want to see, you have several options available. You can use any one of them. So for the active and the reactive power, so I have bus 4 to bus 5 circuit 1 megawatt, right? So I simply copy it and will paste on the second identifier and make it megawatt. So I have this done. Go. Now my 2 channels have been added with this identifier. In the next step I need to add 4 to 6, right? So I will go from here, select from 4 to 6, and here it will become from bus 4 to 6 megawatt and bus 4 to 6 megawatt. I press go. I have now these channels selected. How can we see these channels? Seeing is simple. Control tab, go to your Dynamics data, go to channels, and in channels now I have these channels added. So everything is okay. This is the minimum requirement for my transient stability analysis. Now there is one more option. If you remember, when we were performing this basic analysis, we wanted to find the relative angle. So for the relative angle we had to create this function a minus b. So if you do not want to create this function, you can use another way. So what is this way? You can simply go to Dynamics, Solution, Options. In the solution options, you have different things. You can add network dependency, or you can scan your system against generic relays. You can scan for auto step condition. You can monitor as well as trip. You can scan for buses outside of voltage range. So here, from here, what I'm going to select is select relative machine angle. So because I am performing my analysis, so you can have different ways here also. So you can select your any bus here or any generator here, and all the relative angles will be respect to this. So you can select this, but now my idea here was to tell you about this, but I will not be using this. Then this is the first thing. And the second thing is you go to dynamics, you go to simulation, and you have solution parameters. So these solution parameters are also important. Now that we are solving a small case, for the small case maybe these default parameters will be okay, but if you have a larger case, these parameters may not work. So for this purpose, always remember you can change these parameters, and the simple way of changing or the benchmarking is, if you have a bigger system, always make your habit to use iteration around 200, acceleration factor around 0.4, and this delta value, this should be at least quarter of your cycle. So what do I mean by quarter of the cycle? By this I mean that you have in this case my frequency is 60 hertz, or in your case the frequency will be 50 hertz, right? So for a 60 hertz system I will calculate for 60 hertz system, you can calculate for 60 hertz. For a 60 hertz system, what you will do, one cycle, this will be equal to 1 divided by 60, right? So this is equal to 0.0166 in my case. So what will be the quarter of this? So simply divide this value by 4. So this turns out to be 0.0041. So if I use 0.0041 here, my simulation should be okay. So always try to use quarter of this time step, quarter of the time cycle. For the 50 hertz system, if you have done it, it is good. If you haven't done it, so simply you have to 1 divided by 50, right? So this gives me 0.02, and further divided by 4, this is going to give me 0.005. So you can use this time step of 0.005 when performing simulation for 50 hertz system. So I have done this, so I will press OK. Now I have adjusted everything I want in my case. So now what will be the next step? I have to save this case. So saving is simple, Control S. Make sure you have snapshot data file, and now in this case IEEE 9 updated snapshot file. So I am saving a snapshot file, press OK. My file has been saved at time is equal to 0.0. So now all my things are ready. Now I can perform simulation. So to tell you again, what is the simulation we are performing? 3-phase fault on bus 4 and tripping of line 4 to 5 with 100 milliseconds. So let us do this simulation now. So how can we do this simulation? You can either go to disturbance, simulation, perform simulation, or on this toolbar there is this option dynamic simulation. You click on dynamic simulation, perform dynamic simulation window will open. We have already gone through this. Let us select. So what we have a 3-phase fault, and we are checking transient stability analysis for fault bus 4, then trip 4 to 5 with 100 millisecond time delay. So you can use whatever you want. So this is my explanation, or this makes me feel easy with this, so I'm using this. So you can use whatever explanation you want here for the name. This is just a name. So when I press open, I have my file selected. So now what will be the next step? To initialize the case, because if you see here my case is not initialized. So simply to move on, I select one. It is no needed, but I do it every time because the next step will be to run the case for 1 second, so it makes it easy. so it reduces one of my step. So what I do, initialize, initial condition check OK, it means everything is good. The next step is to perform the simulation up to 1 second. So I run my simulation. Simulation has run for 1 second. Now I have to initiate a 3-phase fault at bus number 4. So for this purpose, I will go to bus fault. You can go from disturbance as well. I have directly used it from the toolbar. I will select my bus number 4. Okay, you can have simply written 4 number. Minimum possible impedance we are using, so that is why it is negative. And when I press OK, my fault has been added into the system. Let us run for 100 milliseconds. So I am standing at 1 second. Now I have to go to 1.1 second because now my next simulation event is for 100 milliseconds. So 1.1, right? So we run. The fault has been simulated for 100 milliseconds. Now that we have to clear the fault. From the toolbar, you can go from disturbance. I am going from toolbar. So clear fault. Go. The fault is cleared. Next step will be to trip the line. So I will select trip line and select from bus 4 to bus 5. So this is the line I want to trip. I press OK. So circuit 1 from bus 4 to bus 5 set out of service. It has been tripped. Now the post disturbance simulation needs to run for up to 10 seconds. So we select 10-second time here and we press. My simulation is complete. Now I'm going to press close and everything. No need to save the case at this point. Please do not save the snapshot file once you have done the simulation. Always select no to save the file. So now my first simulation is done.